Okay, so what is the topic that we are doing in grade 11? Well, what we're going to start today with is basically the laws of exponents. And then we'll do some stuff with equations, and then we'll do some stuff with simplifying surds, and then we'll solve some surd equations. So if you like, you can take a screenshot of this page. It shows you the progression, like how in grade 10, what you were dealing with, and then this is kind of where we are now, but we also go back here a lot of the time to practice. So take a screenshot if you like, and then give me a thumbs up when you're happy to move on. I just like to show students where we're going. Awesome, awesome. Okay. So what we are going to do is we are now going to do a multiple choice question, because I love a good multiple choice question. You're going to find this out about me. So let's just warm up, like a good, sports person. Got to warm up first. So let's start with this. Which of the following is a power of 5? Is it A, B, C, or D? Which of the following is a power of 5? A, B, C, or D? So when we say powers of 5, I want you to think. I know 5 to the power of 1 is 5. 5 to the power of 0, well, that's a sneaky one. 5 to the power of 2 would be 25. And I agree with you guys. I think that D is going to be the correct option, because 125 is just 5 times 5 times 5, or 5 to the 3. Okay. So that was the warm-up question. Don't worry. We will keep on swimming, as I like to say. Let's go to the next question. So this is a multiplication of two numbers with the same base. And which of the 4 options do you think is going to be correct? Now, this mirrors one of the change of base laws, or not change of base, what happens when you have the same base. Oh, Kirsty's in the house. Thank you, Kirsty. So Kirsty is acting as our super tutor today. She's not just in one class, she's in 3. Okay, so let's have a look. So we know from exponents in previous grades, as long as the bases are the same, then what do we have to do? Maybe somebody can come online and just tell me, what rule did they think about? So maybe, I don't know if Zandre, if you're feeling comfortable, maybe just give us a talk through how you answered it, or anybody else who answered, what do they think? What did you think about? I can ask you to unmute Zandre, but it's up to you. Maybe you can share with the class what you think is a good strategy. There's a little button at the bottom where you can unmute, although maybe the setting's not working today. We'll call it first day problems. Okay, so all we need to do, oh, there we go, Buchle. Oh, I'm unmuting someone. How's it going?
So I think good in you, sir.
Good, good. What can you tell us about how this works?
Well, what I can tell you, one of the rules states that if the base is the same and we're multiplying that same base, then we just have to add the exponents.
So the base is the same, and then we just add the exponents. So there's a 4. And then here, so did you get 3 to the 7?
Yes, sir.
Perfect. I agree with you. So what Buchle is saying is that, look, if you have the same base and they're being multiplied, now that's a big if. So if I gave you another example, 2 to the 3, in fact, let me do another one and we can use this question again. If I say to you 3 to the power of 4 times 3 to the power of 8, which of the 4 options would be the answer to that question? Which of the four would be the correct answer to that question? So is the base the same? Yes. And now we go 4 plus 8, which is going to be an enormous number, but it should be B. So that's called law 1 for exponents. We'll say law 1. And if you really want to be fancy, what we sometimes do is we say like x to the a times, actually that even looks scary. Let's make it like, I don't know, a to the x times a to the y equals a to the x plus y. Now that looks more frightening than it is, but all it's saying is that, like you add the powers if the base is the same. Okay, so as long as this is the same, then you're good. Okay, so let's move on. I know, Kirsty, I'm feeling it. I'm also feeling how nice it is to be back. I'm enjoying being in the classroom. Okay, next one. So it's no longer multiplication. The bases are the same, which is good for us. Which of these four do you think is the correct option here? Which of these four? So I see Zandre, Boucle have voted. We don't know if they're correct, but we'll what do you think? There's some good research that says even if students don't know the answer, if they commit, they learn something. So even getting it wrong and learning helps you better than not committing. Okay, Gemma, would you be willing to tell us how you did this question? If you are, just pop your hand up, or Zandra, if you're willing, just pop your hand up and tell us what you thought about when you did this question. It's always nice to get to know students as we go. But I understand also it's an interesting environment. So, oh, Palesa, welcome, Palesa. Okay, so if we look at the bases being the same, that's good news for us. But the law is slightly different. So you write down the base, but now instead of adding, you subtract the powers. And so we should get 2 to the power of 5. Which of the four options is that? The correct option is going to be B. And let me do what I did last time where I remix a question. So I want to say now I'm making up my own copy, and I want to know what is 2 to the 9 over 2 to the power of 7. Excuse my twos. But I want to know what is that going to be equal to? Which of the four options is that going to be equal to? Using our laws. Don't hold back. Exercise your democratic right to vote. Okay. Yeah. So it seems to me like A is the correct answer. And let's understand why. Well, the base is the same, so therefore we can subtract the powers. So we get 2 to the power of 2. We get that. Give me a thumbs up if everything's fine so far. Give me a thumbs down if you're feeling a bit lost. What does that law look like if we write it out? It looks something like this. So that's what law 2 looks like with exponents and rational exponents. Okay, let's keep swimming. If you have this, and notice how I'm warming up here. It's like the questions are getting more exciting. What do you think the answer to this is? I want you to think about what's law 3. Okay. Now, this is a bit harder, so I'd love someone who maybe has some prior thoughts on this question to say, what's going on? What does it mean if we have a number to a power and then to another power? What I will say, Buchle, yeah, let's go to you.
Well, doesn't
Buchle,
it
how
mean
would
so
you
that,
explain this to a student in class?
well, if we have a number with a power within a bracket and there's another
Yeah.
number that is the exponent of that bracket, then we would have to multiply the two exponents together. So then we would say 4 times 3, which would make
Okay.
5 to the power of 12.
Okay, so let's see if I can, Buchle, just tell me if I'm reading what you said. So you're saying that means 5 to the power of 4 3 times, and you get then 5 to the power of 12, or you could have just gone 4 times the 3, and then you get 5 to the 12. Would that be a correct description of what you were saying?
Yeah, just 4 times 3.
Yeah.
Not 5 to the power of 4
Okay.
3 times, just 4 times 3.
Yeah. Okay, so the law, so there's 2 ways you can do it. Thank you, Buchle. So what Buchle is dealing with is there's a law that says if you have a base to a power, and then there's another power outside that, all you need to do is multiply those 2 numbers, right? So in this case, it was 4 and 3, so 4 times 3 is 12. But just to show you where that comes from is something to the power of 3 just means repeat it 3 times. And so that's why another way of seeing it is like this, but I'm going to rub that out because we can go with that. Okay, I'm going to make another remix question. If I say to you, what is the answer to that question? What is the answer to that question going to be? A, B, C, or D? What is the answer to that going to be? What is the answer to that going to be? Students are unanimous in that. Well, let's have a look. Callan has said A, is Andre says A, Gemma says A. Okay, so I think you've got this one where you know, look, all I need to do is that, and I get 5 to the 12. Perfect. Okay, so this is law 3. So we've covered what we call the addition law when we multiply and we add the powers. We've got the subtraction law, and now we've got the multiplication law, which we've just used. Okay, now there's another definition that comes up in exponents and surds. So what is 7 to the power of 0? Cast your votes, people of grade 11. What did your
1.
teacher tell you about that? Ah, someone knows it. Who was that? Tell me, why is it 1? Who was, I didn't get the,
Because anything to the power of 0 is equals to 1.
yeah, exactly. So the law says anything to the power of 0 is 1. So it doesn't matter what the number is. If it's the power of 0, it's 1. And one of the ways to see this is like what is 8 over 8 going to be equal to? What is 8 over 8 equal to? You can pop your answer in the chat. Yeah, I think 8 over 8 is equal to 1. But we also know, okay, we also know that 8 would be 2 to the power of 3 over 2 to the power of 3. Now, using the law 2 says that if the bases are the same, you subtract the powers. So the base is 2, and what do I get if I subtract the powers? I just get 0. So you can see that we can say 2 to the power of 0 is 1, and we use this argument for all exponents. So whenever you see a 0 to the power of something, I want you to know it's 1. Cool. Okay. Notice how tricky I make the multiple choice. I really test your understanding. Can you simplify this expression 4 to the power of 6 divided by 4 to the power of 3? Which option do you think it is? Welcome, Pilar, and welcome. I see a couple of students have joined us. For some students, they might like it more if I wrote the question like this. But it means the same thing. Okay, who would like to, I suppose you guys can see this. So tell me, which law is this? Is it going to be law number 1, law number 2, or law number 3? Remember, this is the plus, that's the minus, that's the times. Which law is going to be relevant here? It's going to be law number 2, and I go, the bases are the same. Therefore, I subtract the powers, and I get 4 to the power of 3. Is there a 4 to the power of 3? It is here. Just want to stop for a second and ask, are there any questions or comments from students? So does anybody have a question they'd like to raise? Otherwise, I'm going to move on. You're doing well. Like, students struggle with exponents, and so you've got the 3 basic laws. Okay. This gets a little bit more tricky, but maybe we can brainstorm this together. We can do this together. Why is this question more difficult than the ones I've given you so far? I'd love a student to tell me. So all I want to know is, like, what makes this trickier than the last one that we were doing? Because it does seem trickier to me. Okay, so Buchler said the bases are not the same, and Buchler, I agree with you. This makes my life a little bit of a headache. Is there any way that we can get around this problem by maybe changing one of the bases? Who has an idea about how we might be able to change one of the bases? I'm teaching my grade 8s at the moment, and one of the things they do is they break down numbers into smaller pieces. Can you remember that section from grade 8? Well, I don't know, maybe you guys were, grade 8 was probably COVID year for you guys, but if you think about the number 20, would you be okay if I wrote it as 5 times 4? So give me a thumbs up if you agree that 20 is 5 times 4. So if I had to rewrite this question this way, I think what I'm going to do is where there once was a 20, I'm going to use my mathematical knowledge to say I now have 4 times 5. Okay, so now here is the interesting thing. Can we break apart the 4 and the 5 to be separate? So I want to suggest that there was a law 3, whereas if you have a power outside, what do you do with the 6 inside? How do I get these guys to play nice together? Who would like to explain, or maybe have a shot at explaining? This is hard, so there's no guarantee you get it right, but I'd love a student to have a crack at explaining what they think we do next if they feel comfortable. It really helps to hear someone else think through it. So just pop your hand up if you're feeling like a ninja tonight. Otherwise, I'll give a little brief explanation in a moment. Okay, I see Bukle. Bukle, give us a little bit of a thinking process. What are you thinking when you see the 6 outside?
Well, because if we look at law 3, it says that if we have a number with an exponent within the bracket, we just multiply the exponent outside of the bracket. So the exponent of 4 is 1, and the exponent of 5 is 1, so we've just multiplied with the 6. So both of them would be 4 to the power of 6 times 5 to the power of 6 over 4 to the power of 3.
Okay. So if we look at that, we can now get to that step. Now, here's the thing, okay? This is a tough question, but and I'm not going to spend too much time on because we need, it's a bit too tough for this early in the lesson. But the bases are now the same here. And so what I can do is I can say, look, for the yellow bits, it's just going to be 4 to the 6 minus 3. And over here, I'm going to have that. Give me a thumbs up if you followed this bit, how I got the bit in yellow. The bases are now the same, so I subtracted the powers. Give me a thumbs up if you followed, or raise your hand if you have a question you'd like to ask. So what I see now is we have 4 to the 3, and instead of using a dot, I'm just going to say 5 to the 6. Now, this is definitely not C, it's definitely not B, and it's definitely not A. So what's the only possibility that's left for this question? This is a toughie. This was a real toughie. So it has to be D. Okay. Let's do one more before we have a break. I want to do this one before we have a break. M squared times m cubed equals which of the 4 options? So this is law number 1, where the bases are the same. And so all I need to do is add the powers, and I should get m to the 5. Is there an m to the 5? Yes. It's going to be A. So that was actually quite an easy one. Maybe we can have... Okay, let's save that for after the break. Okay, grade 11s. We have been doing maths for half an hour now. It is important that we take care of our brain so that our brain takes care of us. So what I want you to do is, and I know this is unusual, not every teacher does this, but if you can, turn on your screen so that we can see each other, and we're going to do what's called a brain break, or a little exercise break together. And it's just going to be a minute just to get our bodies moving. So turn your cameras on, and I will show you my little room, and I just want you to stand up with me. And what we're going to do is we're just going to get our heart rate up so that our brains have a break. We want to give our brains something to worry about. I mean, other than maths. Okay, so I want you to make sure that you have a space around you that is clear, that you're not going to whack anything. And all I want you to do is join me in doing 10 jumping jacks. A jumping jack goes like this. And I want you to do 10, and then you should feel your heart rate jump around a bit. Okay, are you ready? 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10. And ooh, our brains are hopefully now pumping, our hearts are pumping blood all over our body. And maybe you looked a bit like, look, this is working. You know, we want to show some enthusiasm. So how are you feeling after a little bit of an exercise break? Or did you sit out our exercise break? I'm not sure if did Teacher Coco do exercise breaks? So I know there's something about blood pumping around your body that's just so awesome. And I mean, look how happy this guy is. Who wouldn't want to jump around a bit? Okay, I'm not going to do, because we're short on time today, I'm not going to do the puzzle, but normally we would do a puzzle at this stage. And actually, you know what? Screw it. Let's do the puzzle. So I want to know, what is a red sweet plus a purple sweet times a blue sweet? I want to know, where do I start? Where do I start with this? This is just a fun logic puzzle, just to give us a break before we head into the second half of the lesson. No problem, Stephen. Today is all about just getting on the bus. So that's the main thing for today. We just want to get used to the environment. Palesa, we are going to do more. We did multiple choices already, and we're going to do some more. So I think we start by doing this one. So what is a blue sweet going to be equal to? Just pop it in the chat. So we are going to get 3. Stephen agrees. 3 times 3 times 3. And over here, we're going to have 3 and 3, which is 6. Here we have 3. So now what is one red thing going to be equal to? What is each red going to be equal to? Well, if this is 6, then this whole thing has to be what? It has to be 2. So what is a red sweet going to be? I think 6 times what gives you 12? It has to be 2, and each of these, there we go. Stephen's got it. 1 and 1. It's a 1, and that's a 1. Okay, last little bit of the puzzle. What does the purple sweet need to be to go something times 1 is 16? Something times 1 is 16. Okay, so indeed it's 4. So what is the final number going to be? Sandra agrees. What is the final number going to be? We need to know some BODMAS. So 1 plus 4 times 3, what does BODMAS say, or PEMDAS say that has to be? Okay, BODMAS says do this first, and 4 times 3 is 12, and then there's a 1 there, so we should get 13. 13. Okay. All right. I hope you enjoyed that. I always like a little puzzle, a little bit of fun. I find my brain enjoys the novelty. So let's go back to doing some practice questions here. And all I want to do, actually, let's do these ones. They have a few more variables. So I want everybody to try and do question 1, 2, and 3. And what you can do when you've got the answer, put your answer in the chat. No problem, Buche. That was just an adding up error. In the chat, if you want to give power, just use this little cuppy symbol. But I want to give you 3 minutes or so to just have a go at question 1, 2, 3, and then we'll get some feedback from students. And if you're really feeling like today is your day to shine, then take on question 4 and see if you can simplify that without a calculator. Okay, okay. And yeah, if you have a question, what we can do, what we did last year is this is a great time to raise your hand and we have a bit of a chat as to how we go about solving these questions. But if you want to work, then go ahead and I'll wait for the answers in the chat. So just while you're working, for question 1, what law should you be using? Looks to me like it's the same base, and I'm law number 1. Yeah, law number 1. And so law number 1 says we write down the base and we do something. Here we write down the base and we do something. Here, I guess we do something different, but I'll give you some more time. Who would be willing to share their answer for number 1? Gemma, how are you feeling? Would you be willing to share? Callan, talk us through how you did number 1, or just give us your answer. Share your thinking with us. That's what I'm most concerned about. What processes are you using? And it's much easier to see that when you are having a conversation. Who feels like they can share some knowledge with their classmates? Okay. Well, I see Brooklyn said in the chat, add the exponents. Stephen has said y to the power of 2n, okay, plus 5. Yeah, so you just have to take these two parts and you add them together. So that's perfect there. What about number 2? What should the answer be for number 2? Okay, so for number 2, we've got a, but now we need to subtract the powers. So we know the bases are the same, but we subtract the powers. But what do we get when we subtract those powers? Well, 3n minus 1n gives us 2n. And Callan and Zandre definitely get that. So that's perfect. Okay, what about number 3? Number 3 has one base to rule them all. But what are we going to get for our answer there? Yeah, so this is law 3, you multiply the powers and you get x to the 8. So the 2 times the 4. All right, let's try and do number 4 and 5. Now, 4 and 5 are harder, so there's different ways we can do them. I want to ask for some tips from the class about how they would approach this. You can put it in the chat and I'll read it out, or you can raise your hand, it'll be quicker. What approach would you use for question 4? Because not everyone in the class is going to feel comfortable answering this question. So we need some thinking tools we can use. Who has some ideas they can share with their classmates? Where would you start? It says, simplify this without using a calculator. Where would you start? What law does it remind you of? It's kind of a long and a short way, I think. But that's my perspective as a teacher who's been teaching for many years. Give it a go, and I'll give you some time, and then you can give me some feedback. For some reason, this is reminding me of law 3. Give me a thumbs up if you guys are feeling like the power that's hanging out outside here somehow maybe comes inside. Like, that's what I'm feeling. So because these ones don't have powers, I'm going to give them powers. They're like phantom powers. And Gemma said multiply the exponents in the bracket by 3. So Gemma, I think you've got this. But I can't just multiply that by 3. I also have to multiply the ones on the bottom by 3. And so then I'm going to get 3 times 1 is 3. This is going to become x to the, so 2 times 3x to the 6. This is going to become 3 to the 3, because there's a 1 there, and this is going to become y to the 9. So if I look at that, does anybody have, well, give me a thumbs up if you follow me on that. So at this point, normally in these questions, right, you would start by seeing, can you cancel anything on top and the bottom? But you can't really cancel. Like, all you can really say is, well, 2 to the power of 3 is 8. And so I get 8x to the 6. 3 to the power of 3 is just 3 times 3 times 3, which is 27. And that's it. But often in these questions, something will cancel out, and that's normally what would happen. Okay, let's try and do number 5. What makes number 5 hard or harder? What do you like? Oh, why has this teacher put this part in the question? What gives you the most stress when you look at it in question 5? So I was thinking, maybe you agree with me, give me a thumbs up if you do. It's this minus. Minuses tend to behave badly. So the question is, how do we deal with the minus? Well, what I do is I put a little bracket around it and I give it a 1. And then I know, like before, the 2 gets multiplied by each of the things inside. So I end up with, let's say 1 times 2, and then this can be 3 times 2. So then I end up with y, so now 3 times 2 is 6. What's minus 3 to the power of 2 going to end up being? What is minus 3 to the power of 2 going to end up being? Yeah, and this is what's going to catch students. It's that fact that a negative times a negative is a positive, and I get 9y to the 6. So if you look at what we started with today, we started with reviewing the laws of exponents. We looked at one of the definitions where something to the power of 0 is 1. And now we've practiced 5 questions where you have to apply the laws. Okay. Now there's one other idea that I want to talk about before we end today, and that is something called negative powers. So if I have 2 to the power of -1, if I have a minus power, there is a way of changing this to a positive power. And I want you to finish with this today. How do I get 2 to the minus the 1 to become a positive power? Well, the law says anything can be written over 1. And if you bring this below the line, right, there's always going to be a 1 left on top. If you bring this exponent and base below the line, it changes sign from positive to negative. And so what you have is that 2 to the power of -1 is equal to a half. Palesa, it's not -9 because in the previous question, it's going to be -3 squared, which is -3 times -3. And a negative times a negative gives you a positive. So that's why it's actually one of the sneaky bits. So, like what I was saying, if you have the law looks like this. It says, look, if you've got something to a negative power, you can make it a positive power by simply changing or bringing it below the line. Give me a thumbs up if you have seen this. This is called a definition. If you've seen this definition before with exponents. Give me a thumbs down if you've never seen how to deal with negative exponents and change them to positive. So what I want to do tonight is I want to finish with one last question. And we're going to deal with negative powers a bit more in the next lesson. But to finish tonight, I want you... What should we do? Let's do this. So if you rewrote this question, it would look like that. Now, the negative powers are giving me a bit of a headache. So I want to know, what can I do to make things be positive powers and give me less of a headache? Is basically what it boils down to. Give me a grandpa. A grandpa headache power, that is. Flip them over, yes. Or another way is move this to the top and move this to the bottom. So using that definition, I've now got, now what's interesting, and my brain was like, why aren't you moving the 9 and the 27? But the reason I'm not moving the 9 and the 27 is they don't have negative powers. But part of me really wanted to move them, but I knew from experience I should resist. Okay, what is this going to be? What is x to the power of 3 over x to the power of 2 going to be equivalent to? Well, they don't cancel out exactly. What is x to the power of 3 divided by x to the power of 2? So the base is the same. And it's just going to be 3 minus 2. Yeah, so it's going to be x to the 1. But I've also got to deal with the 9 over 27. But I want to make it easier. What is 9 over 27 equivalent to? Or what technique could I use to simplify 9 over 27? So 9 over 27, 9 goes into itself once. And 9 goes into 27 times. Question simplifies to 1/3 x. So this whole long thing, by using the various laws, you can simplify it down to 1/3 x. And that is a great place to finish for tonight. I just want to recap what we did. We looked at the 3 basic laws of exponents, and we looked at the two definitions and we applied them to more and more complicated expressions. In the next lesson, we are going to start to look at some more complicated exponent questions where we have to simplify them. And we're going to go from there. But just, yeah, as we finish today, I just want to say thank you so much for being here today. It was lovely to start teaching again.